Welcome to a video on graphing piecewise defined functions. As noted here, remember to pay close attention to the input restrictions for each of the piece before graphing the function. To begin, let's define the first piece of the function as y1. We'll graph this function without its restriction first. So note that this is a linear function. To graph a linear function, we can start with the y-intercept, which is 0, 5. And then use the slope of the equation to determine another point. So the slope of the equation is -2. That means we move down 2 units from the y-intercept and 1 unit over. Remember, the slope of a linear equation is defined as rise over run. Since it's negative, we go down 2, and then we run a +1. Now we can continue using the slope to obtain another point. So rise -2, run 1. Here's the third point. And rise -2, run 1. And from here, we can simply connect the dots with a line segment. Now we can consider the restriction on the input value of the first piece. So the function h of x is defined as 5 minus 2x, provided that x is less than or equal to 3. So here's when x is equal to 3. So on the graph of that function, we want to include all the values from 3 and going left, since it's less than or equal to it. So we want to include this point here due to the equality symbol that's associated with that inequality sign. And then everything to the left of that we want to keep. So I'm going to delete this segment of the graph. And so basically connecting those points again, where x ends at 3. And now to graph the second piece, let's go ahead and call that y sub 2, which is -4. Notice that this is a constant function. And so a constant function is just a horizontal line at -4. Without looking at the restriction on x, this would be the graph of y2. And now consider the restriction. This is true for x greater than 3. So for x greater than 3, that means do not include the value 3. So we're going to use an open circle on the graph at x equals 3. And we want everything to the right of that line. And therefore, I'm going to delete the portion to the left of it. And hence, together, the purple and the red pieces of the graph make up the graph of h of x.